How are you? Are you there? All right. Okay, today we go for revision before your test two. So today we will focus on revision and we will not have class on Thursday. So will be covered today. We do some revision. So your test two will be on 30th of June and nanti I'll inform you lah regarding your test, the information I will all the instruction. Either similar like test one, it will be have at night, not during the day, masa malam, pukul 8, if I'm not mistaken. Nanti I forward to you the direction and so on. Test two, 3 question. As usual, 3 hours, I think. Not sure, 3.5 hours total. First question will be bearings. Second question will be reverb. And the third question will be gear strength. Okay, gear strength this semester we have 2 parts. So the gear strength we have 2 parts of question. One is the main thing is a gear bending strength, and the second part will be gear surface strength. So it will cover two type of strength for gear. You have to study for your bending strength, how to get the safety factor, and also surface strength, how to get the safety factor. Okay, let us do revision for this test one. Okay, we begin for bearing. First question is bearing. Okay, loud and clear. Hello class. Sound saya okay ke? Cannot hear me clear. Why? Sekarang okay? Kalau tak clear, inform me, Ijan. Ijan, are you recording? Okay, thanks. Okay, the first thing is about kita revision about bearing. Okay, remember I did share you in the WhatsApp previous semester. Last 2 years can let's discuss one of the set. Okay, let me share you this Firefox. I think I already put in your e-learning. Let's go for this test 9. This test to 2018-2019. Let's go for that. Let me show you. Okay, boleh nampak this one guys? Hello class. Test to 2018-2019. Okay, let's we do some revision. Okay, first question as usual is bearing. If you look in this set of question, we have a system with we have a spur gear C mounted on the shaft A, B, C, D. We have a spur gear and we have a pulley. Okay, at C we have a spur gear C at C and transmit power to a V-belt pulley A. Okay, it means transmit to the pulley A. We have pulley A. Shaft ABCD rotate at 2000 RPM because this question one is about how you select bearings. And always read the question, guys. Always read the question. Moderate shock. Okay, this one because this is about bearing, guys, and you want to select bearing at B and D. Okay. Okay, we have spur gear at C and we have pulley at A. Okay. Okay, the shaft is supported by two bearings. One bearing. Okay, for the transfer power with a moderate shock, because remember bearing, either you calculate CREQ or you calculate life, but normally you calculate required capacity, CREQ. CREQ is KA, application factor, times FR, your radial load. Looks at my live video, boleh nampak my live video about bearing is CREQ. That's what is what we call KA is application factor. FR is total radial load on your bearing. Be careful, this radial load, when your bearing have thrust load, you have to get the ratio to get the F equivalent that will replace into your FR here. And times by your, what we call this thing, life, and your life, okay, life or of your system, and KR, LR. Okay. Ya ke? Hold on, ya. Okay, macam ni Kejap. Sekarang pun tak fokus ya? Ya. Hold on, class. Hold on, ya. Hello, class. Are you with me, class?
Yes, doctor.
Hello. What about the video right now? Is it okay? Alright, okay. Okay, sorry guys. So technical problem. So we continue. Okay. I share you the. Hold on. All right. Class. If look at the previous semester. Okay, boleh nampak question ni soalan tu 2018, 2019. Class, are you with me? Boleh nampak the question ni. Okay, sekarang the first question will be bearing. So this past years punya ni 2018, 2019 Okay, we have a spur gear at C and we have a pulley at B. Okay, the system runs. Okay, tengok we read the question guys. Okay, the shaft rotating 2000 RPM. So you can calculate live from here. Live. So we are talking about bearings. And okay, the shaft is a transfer. Okay, ni moderate shock. Transfer power with a moderate shock. This is about your. Remember your equation. CREQ is KAFRL over KR is a reliability factor. KA is for your K application factor. FR is your total radial load on each bearing. LR is 9. Standard life is 9 times 10 to the power of 7 cycle. And this is a life that, what is the life of your system? This one to the power of 0.3. Okay, let me recall balik the notes. The notes from your PowerPoint. If you look on your PowerPoint notes, bearings. Okay, let me share you. Boleh saya nampak PowerPoint? Kalau boleh nampak PowerPoint, kelas. Hello, kelas. Alright, boleh nampak PowerPoint boleh kasih. If you look the basic question for this bearing, we have, okay, tengok guys, we have, okay, sometimes the question you asking about life. If you look on the, if I ask you to study both, both of the, if you look on the test to 2018, if I share you, okay, there is, I don't want to discuss here, this one I discussed with the previous section. Okay, this question is 2017-18, the life, okay, find the, determine the bearing life. Okay, look on the solution. I already shared in the WhatsApp how they solve it. Okay, this kind of question, they are asking about life of the bearing. But this question is as typical. Okay, we have two types. We have either calculate life. Okay, calculate CREQ is our rated capacity that we need to find for bearing. And another sometimes question asking you about life. Life, when they're asking about life, class, are you listening? Look at my live video. KR, the equation is one, the top one. KR is a reliability factor times your LR is your 9. LR is a standard life, rating life, 9 times time to the power of 7. And here inside there is your C. This is C10 plus C10. If C10 means the one that you get, remember on your bearing, you look from the table, table 14.2, right? In your textbook. Let me open the textbook also. Textbook on jauhin bearing would be chapter rolling element. Chapter 14 will be bearing. Okay, kalau they ask you, if you look, they ask about life. If you look on the set of question, and this one, question of 2017, they're asking about life. Is life and both bearing is ours or reliability 98%. It determine the life in hours. In hours, that is not we are calculate sehari ke, we mean we calculate life. So in that case, we use this equation. For life is we use this equation to calculate life. This is a basic one. Life is KRLR C10 over your application is here, and this is your FR. FR is the total radial load applied on the bearing. But if you have thrust load, make sure you take the ratio. Go for the equation Y. Equation Y is the to get your FE. So to calculate life is here. This one apa 0.3. 0.3. So in this case, C10, so you mean you got to find your C10. That's my point. You get to get your C10 from this table 14, table 14, mana table 14, not 41 2 is the is your bearing code number, right? Your table 14.2. Table 14.2 is based on C10 life. C10 it means your 90% reliability lah, C10 life. So this is how you get you punya C10 here. So you look on the solution guide. Today I'm not discuss about this set of question. You look on the solution I already given to you. I already given to you in the WhatsApp. So I'm talking about this question. Okay. Okay, this question is 2018-2019. Okay, compute the total radial load acting at bearing B and bearing B and D. Okay, so given already the shaft A, B, C, D. Bearing will be at B and also at D. He said one, okay, bearing and, okay, he said one bearing at B and one bearing at the shown figure. Question 1, the bed tension, okay, the bed tension already given. F1 is 150, F2 is 200 Newton. And the force, gear force already given, F3, F4 already given. Then the system will last until, okay, this is already life already given. Life is already there, 25,000 hours. Okay, 25,000 hours, then you have to convert to cycle, convert it to revolution, or cycle. Okay, nanti kita go for that. Okay, first you have to find what the total reaction load acting at bearing B and D. This one I think is straightforward. You must know lah guys. So you have a system. This is your, you have at me, we have pulley. So we have bearing at pulley at A, okay, and we have bearing at B. Okay, we have pulley at A with angle. Be careful. Let's say this one is 45 degrees. So you must know. You don't have to draw shear diagram, moment diagram. You're wasting your time. You will not analysis on shaft. This is what we only select the total, just the free body diagram in XY plane, the free body diagram in XZ plane. Understand tak class? Class, are you there? Untuk bearing, jangan you buat your free body diagram XY plane. Don't waste your time to shear diagram, moment diagram. You are totally wasting your time. That one you want to shaft analysis. Just a free body diagram on XY plane to get the reaction of bearing at D. So this is a bearing at D, right? And is A is fully bearing is at B, and we have gear is at C. C here at this quadrant they have. Be careful about your free body diagram there. So this we have F3 and we have F4 here. Okay, sometimes the question it will be helical gear. Like this one, if you look at the set of this equation yang 2017, 2018, this is helical gear. Remember helical gear, we have axial force. I think this is already given for your assignment if I'm not mistaken. Am I right? This is the one I gave you assignment on bearing, right? So, you have total axial force. Total. You look on the solution. We're not study on this. We are study on this set. All right. Okay. This one. For this. Okay. We will see, and also we have bearing at D. So we have bearing at D and bearing at D. Okay. So it's given that this is your X, this is your Y, and this is your Z. So you can make a free body diagram. I don't want to, we don't have time guys to calculate everything, just give you some idea. So just XY plane,
So what do we have here, SY plane? What is the free body diagram? A, B, C, D. Okay, tengok if you look here, B, okay, this is, we have force here. We have force F1, F2 is given. A is given, F1, F2 is given. F1 is 450 Newton, F2 is 200 Newton. So that will be total force because this is sine 45. Be careful, right? So your okay, this is your XY plane. XY plane, you're looking from the left view. So you have at A tu. Tengok sini at A tu. At A tu you have total, okay, this force downward from the pulley. B will be at your A, and you have a bearing. Okay, B is bearing since this is a force. Totally the force is more toward this direction. Your bearing will be in terms of BZ and BY. So in term here we have BZ. Because it's pulling this direction, your BZ will be here. So your BZ will be here. And also it's pulling this direction downward, and your BY will be up. Understand that? Clarity will be your BY. So we need to find what is BY and BZ. So from XY plane, we can see only BY. So BY is up. Okay, BY is up. And let's see. Are you looking at my live video? Guys, clear? Okay, class. Hello, class. Live video. Okay, see. And C, we have C is we have F3 here, and C we have F3 upward. Sorry, upward F3. Everything is known. Okay, what about what is the force here at the pulley here? Okay, and also at D, okay, since the spur gear is F3 is acting upward because we are on XY plane. I'm talking. Okay, we have D, dy. Dy is downward logically because this one is upward. If you put it upward, it's okay. Tapi you get negative, it will be downward. It makes sense lah. It's much easier for you. So dy is downward. So this will be your dy. I'm talking about XY plane. Okay, what about the force here? We have 45 degree here. Be careful about this guy. This angle 45. What is support? Okay, we have 200 and 450. 200 plus 450 is what? Plus F1. F1 is 450, right? It's stated that F1 is 450, F2 200. So what will be here as Y plane class? Yes, 350. Do not put just 350, totally wrong. 350, cos or sine? Same lah, sama kan? 45, cos. You're right, cos Cos 45 degree. Be careful there. So I don't want to, I don't want to solve it for you. We don't have time. So this one, you know the distance. Okay, just this. Do not make shear diagram, moment diagram, right? Wasting your time. This is not shaft analysis. We're not talking about bending stress or in the shaft. We are talking just about total radius. This all get the by dy. Understand kan? You know how to do this start class. And you can get your by, get your dy. Another one is here. Okay, XZ plane. XZ plane. What do we have as a plane? As a plane, we have at A. As a plane looking from the top, guy. So because it is X, Y, Z. Looking from the top. So what do we have? At A, we have downward juga. Okay. Downward juga. 350 apa? 350 what? Cos, sine apa? Looking from the top, class. Tadi, Yijan, be careful. Yijan. This one is sine. Be careful guys. Nanti kalau question your test tu is not 45 degree, be careful. 45 cos sine is the same. Tapi not 45 degree, let's say 30 degree, be careful. This is sine. This is sine 45 degree. Okay? Because XY plane sine. This is cos 45 degree. Be careful about this guys. 350 cos 45 degree. So what about at bearing at B? Okay, now we have looking from the top, we have BZ upward. We have BZ upward. And also here we have gear, spur gear. We have looking from the top, we have downward of the F4. F4 is the radial load of gear. Okay, F4 is also given. F3, F4 is given. F3 is 1,200. F4 is 700. So yang ni this is 700. Okay, F4 700. Yang ni tadi F3 is 1,200. Yeah. I'm talking about super. So you can get your by dy moment. Tahu Fy 0 moment at A. It's simple lah. Do not make silly mistake. Make sure your calculation is right. Well, we have looking for on the top, we have F4 like this, and also we have dz like this. This will be, this now this is dy. dy now this is dz. Can you see? Hopefully you can see my video. Just a small report diagram. So dz. So looking for on top, we have dz upward. So this will be your dz, dz. And you have a distance here. Distance all given. Solve it. Solve it. I just look on the solution. Solution, they solve it. Okay, we solve the solution RBY. This one is solution BY. RBY means BY. DY, okay, already solve it. Clear? So this is BY, this is DY. Solve it. This is BZ, this is DZ. Okay, then you get the total radial load. Okay, in this question, is there any axial force? Yes, they have axial force. Okay, it means it's designed the system. Okay, F5, okay, it said that, okay, first is just get the reaction. That will be at your, you, okay, get your reaction. So you got your BZ. You look on the solution. BZ is 944.936 Newton, and BY is 81.299 Newton, and you get your dy is 81.68. Right. And dz is 214.684. Okay. Newton, it's all in Newton. Okay, okay, that's answering the part one. Part one already done. Okay, part one already. Okay, part two. If this one, you don't have to use your force because just to save you guys, like sometimes students miscalculate, it will affect part two. This one already there is okay. Sorry, part one you have to get the radial load. Get the radial load. Sorry, part one B total radial load. Radial load at B. Total radial load. B means at B. What is the total resistance? BZ. What is total radial load at B? Radial load. Radial load at B is square root dy square plus bz square. So you got total radial load is at B. At B is 948.426. Okay, just put substitute into here. Radial load at B, total radial load. Okay, radial load at B is square root dy square plus dz square. So we got B is 849.263 Newton. So this one is answering your part one. So this is your part one. Okay, answering your part one. Part point is 10 marks on that. Be careful, don't miscalculate. Okay, part two already they save it. Okay, you don't have to use. Okay, because they take the rough value from here. Actually, the part two already have an answer for you. 850 and 5. Okay, the total ratio at B is 950. They take the rough value of this. Okay, say the part two is reaction at B. Yes, yeah, B is okay. Part two, yes, B is 950 Newton total radial load, and at D is 850. Okay, they take the rough value of this. Okay, so if this is the case, if the total reaction for reaction B 950, the bearing D also designed to support the transfer. It means the bearing at B. Bearing at D. This bearing support thrust load. Bearing at B, no. Okay. Determine all the suitable size. Okay. It's also designed to thrust load. Okay. F5 is already given 580 Newton. So it means this F5 need 580 Newton. 580 Newton at one. At here. Okay. We have 580. This one is 580 Newton. 580 Newton of F5. So it means bearing D will be angular ball bearing. It's not. Guys, determine suitable size for roller bearing. So nampak tak, guys? Roller bearing. Don't waste your time. This one radial ball bearing. It means bearing at B roller. Okay. It means bearing at B cannot support thrust load. Actually, radial ball bearing can little bit support thrust load, but totally, if no thrust load, we use either radial ball bearing, not angular, or roller bearing. Tapi roller bearing is much better because it can carry bigger capacity of radial load. But roller bearing, cylindrical rolling, roller bearing cannot support thrust load. So it means at B is roller bearing, angular. Why B is angular? Because anything bearing that can support thrust load, angular. We use angular. D is angular ball bearing. Okay. Determine all the suitable size. So this is typical question. So they mean you have to find the CREQ. Okay, remember the CREQ equation, CREQ. So, okay, so say that D is roller bearing. Okay, I think looking at my note, no, say roller bearing. This one is roller bearing. Ini will be, sorry guys, D will be angular ball bearing and D support thrust load. This one angular, okay? Angular ball bearing. Be careful about this. This one angular ball bearing and this one will be roller bearing. Okay? Roller bearing. Okay, let's go for B. CRQ at B, bearing B. Bearing B, which is roller bearing. Roller bearing. Bearing B, roller bearing. See, we get the CRQ. CRQ. Are you watching or not, class? Are you watching? Bearing B dulu, we focus on. Bearing B dulu, bearing roller bearing CRQ is what? KA application factor times your radial load over your life, okay? Life over KR and R. This one is to the power 0.3. So what will be KA? KA is application factor. KA is said moderate shock. So you look on your nose. KA, ni KA, moderate shock apa? Select point. Moderate shock means what? Cepat sikit kalau kita time very limited. Moderate shock means take the lowest value. Moderate shock, okay. Moderate shock, take the lowest value. What is bearing at B? Roller bearing kan? Roller bearing. Be careful. Roller bearing, use yang ni guys. Are you watching the ni PowerPoint? Yeah. Jangan try, do not make silly mistake. Roller bearing at B is roller. Use the last column here. So it will be 1.1, apa tak? Because take the lowest value, 1. Because it is moderate impact. Moderate impact means moderate shock. Clear class? Class? Clear or not? Okay, 1.1. So this one will be 1.1. So kita punya KA is 1.1. FR is a radial load. What is a radial load? Okay, bearing B, do not thrust load. You don't have to take the ratio thrust load and radial load. Bearing B is typical. Take the B 948. 948 is total radial load at B. So kita punya FR is 948.4. Oh, sorry guys. Jangan cuai. Jangan cuai. I also make silly mistake. Use this one. Use this one. What is the release status? Kadang-kadang kita take yang the value atas. Use this one. 950. Okay, class. Sorry guys. 950. Class, read the question, class. Be careful in your exam. Use 950 because they said bearing B 950. Do not take 948. Take 950. Okay. So, and your L, what is your L? Life apa guys? Life apa? L. S is the life of your system. What is the life of your system? If you take the system will last until 35,000 hours. So life macam mana? Look at my video. Life macam mana? Okay. Life is, okay, the system, they already said 25,000 hours. But if it is not given, guys, take note. If it is not given in question, you can use the table ni, reason life. You can ni lah. Okay, let's say sometimes the question said if machine run 8 hours service, but not every day. You can take 14 to 20. Atau machine run for 8 hours service every working day. You can take 20 to 30,000. Understand that class? Okay. Sometimes the statement in the question said the machine runs continuously 24 hours service. So you must take your life within this range, 50 to 60,000. Clear tak class? Sometimes the question stated like that. It doesn't say 2,000, 30,000 hours, but it said the machine will run for 8 hours service every working day. You can take the life, you take the life from this range. Class, clear, Understand? Table 14.4, Okay. But in this one, it said already 25,000 hours. Okay, 25,000 hours, so with 25,000 hours, so we need to convert to cycle because the bearing, run at 2000 2000 RPM. The bearing time run 2000 revolution per minute. So we need to convert everything in 25,000 hour, 200,000 per minute. So we got to hour is 60 minutes per hour. So we can cancel a minute. Hour cancel. Ya, itu saja lah kan. So 25,000 times 2,000 lah. So this will be your life. So if you look on the solution, the life is life. Okay, 2,000 times. Okay, sorry guys, my mistake. Apa tadi? We have to yalah betul lah, 25,000, 60 betul. Okay. Then 25,000, 2,000. So we get in revolution. This one we have in the revolution. Life is 30 berapa disebut tu? Banyak tu. 1, 2, 3. 1, 2, 3, 4, 5, 6. 3 times 10 to the power of 9. Kalau if I'm not mistaken. Betul lah kelas? Yang that here. Okay, so this will be your life. Okay, what about your KR? KR apa? KR we can reliability. KR is reliability. This KA reliability from the graph kan? Graph. Ni look on your textbook kan? Chapter 14 ni. Bearing. I'm not sure. Look, make sure you highlight for your reliability, life adjustment reliability factor. So your life is stated that the 98% reliability. 98% reliability. So 98. Guy, you watching my slide? My ni class. So 98% reliability. Oh, guys. So 98% reliability, yeah, 0.35, 0.35, 98% say 0.35. Okay, 0.35. So, okay, look at my live video. So your KR is 0.35. So you just put the value. So we have CREQ. Ni bearing at B. Kita not check the bearing at B. CREQ. KA is 1.1. FR is 950. And your life is 3 times 10 to the power of 9 revolution. Okay, revolution, and your KR is 0.35 times your LR is 9 times to the power of 7 revolution. So this one is to the power of 0.3. So we look on the, okay, just put the value there. We have CREQ is at B. Okay, CREQ at B is 4099.77 Newton. Be careful guys, it's all in Newton. Newton, this one will be Newton lah. Jangan miss up kilonewton because we are already convert the force in Newton. So this one will be in Newton. So this is 4.1 4.0999 kilonewton, close to 4.1. So CREQ, so this will be bearing. Okay, if you look, okay, they said that, okay, they said determine the suitable size for the roller bearing. So if you look the bearing at B, this one diameter 30. If you look on the figure already given diameter 30. So we CREQ at B 4.9. Okay, it said that determine all the suitable size, suitable size bearing at why are you listening, class? Are you listening or not? At B. Okay, so our CREQ is 4.09. So 4.09, so it means that if you look on your photo, okay, we are roller bearing and B is roller bearing 4.9. So mana di kelas 4.09 kilometer. It said that so kilonewton bearing at apa determine also roller bearing, and okay at B is roller bearing. Okay, it means our CREQ is 4.09. So why is it they put the 1000? Okay, this you said all bearing. All bearing, it means we use all. Okay, 4.9 for, okay, roller bearing like this guy, they have 1000 series, 1200 and 1300 series. Guy, are you listening? Are you watching the textbook? Table 14.2 ni? Kelas saya kan? Okay, ada, okay. So 4.9, so what is for 1000 series for roller bearing? Actually, the solution is here, but I just want to discuss with you. So from here, 4.9, the nearest is for 1000 series, mana? Yes. 7.2 is the closest maximum. So this one, okay, ball 40, that's why I said. 1000 series, 7.2 km ball. L0. Okay, ni nanti, you have to go for table 14.1. Okay, that's one. And for 1200, the closest one will be, kita 4.9 kan, so it will be 4.4 kan. Ball 20, so see, 4.4, ball 20, okay. And for 1300 series, the closest maximum is this one, the minimum one, 4. Pasal kita 4.099, so this one, ball 17. So that's why I put the, this one, ball 17. Tapi you jangan up until here, you kena go for, okay, for 1000 series, okay, for 1000 series, ball 40. So we go for table 41, okay. Table 41, guys, here, the right column, not the, this one is ball bearing. This one for angular and radial ball bearing. Ball bearing, roller bearing, apa dia cakap tadi? The, kita punya is 1000 series, ball 40. 1000 series, ball 40. 1000 series, ball 40. Roller bearing, 1000 series, 1000 series, ball 40, mana? How do you get it for roller bearing? Macam mana how do you find that? We always go always for ball bearing. Macam mana? Ball 40 ni nampak di kelas ni. Sorry guys, ni Mana? Which one? Come on. This one 203, ball 40. 1000 series, it mean the extra roller bearing. 1000 series mean extra light. Extra light. Understand class? This one is, this is extra light. This is light, this is medium. Extra light, ball 40. Mana dia? Extra light, start by L. Ball 40. Ni kan nampak kelas ni? Am I right?
That
Class?
one isn't it OD?
Eh?
For roller bearing, isn't it we need to see at ball column?
Yeah, my mistake. Sorry guys. My mistake. Mana ball 40 extra light mana? So what is the answer? Yeah, it's extra light, ball 40, L08. Ball 40, L08. L08 will be here. L08 and L08. Just now we got the extra light, apa tadi? 7, this is 7.2 kan? Dia said 7.2 kilonewton, ball is 40 millimeter. Ball is 40 millimeter, so how do you get this thing? Apa tadi? 40 millimeter. Macam mana dia dapat ni? Ball 40 millimeter L08. How do you get that one? Come on kelas, takkan saya, come on. Ball 40. Okay, the answer is ball 40 L08 kan? Ball 40 L08. L08 is here. Yup. Sorry guys, my mistake guys. I don't know what happened to me this morning. This one, this ball. My mistake guys. Saya dah banyak benda dalam kepala. I hope you understand. Yeah, ball 40. Ball 40. Sorry guys. Okay, ball 40 lah, ball 40. Okay, this one is outside. I'm not talking about because I thought this thing they bring they make similar thing. So don't do silly thing. That's what I mean. Okay, this one the ball. This is a ball. Sorry guys. Saya dah cannot recall this thing. Banyak benda dalam kepala saya. Okay, this ball 40. Okay, I hope you guys you know better than me lah. You do the assignment semua kan. 40 and this one understand class simple this. Okay, class boleh? Ni faham Okay, what about the yang tu? The medium series is 4.0 bore 20, right? Medium series bore 20. So bore 20 medium series. Medium series roller roller bore apa tadi? Bore 20 kan? Bore 20 204 bore 20 204. This one lah. Bore 20 204. So it's medium series, okay? This is how you give the code. And tadi we have the one is bore 17 Tadi light series now is medium series 4.9 bore 17. Bore 17. So it means bore 17 for medium series bore 70. L31. Okay? And L3 bore 17, sorry guys. Bore 17 apa saya ni 70 apa saya ni lupa. Okay, 17 bore 17. Bore 17. Here, clear class straightforward like this class. Understand Okay. That's why you got the two. Okay, now is bearing at. Okay, now we have to bearing at E. Yeah, but E you have to be careful, guys. Yang bearing at E is radial ball bearing. Okay, bearing E is radial ball bearing. Okay, because it has thrust load. So because it said that angular end and the angular ball bearing. I mean at D is variable. So you need to get the F, you punya F ni, FT over FR ratio. So your FT just now, we already got FT is given FT at D ni 580. So it is 580 over FR. What is FR just now? Is stated that FR, you don't use FR ni jangan use the part 1. Part 1 849. No, use the 850. Don't use this one. Because it's stated in read the question. 850 will be total radial load at, so this one 850. So got the ratio of that one, bearing angular ball bearing, take the ratio 0.682. So that will be your, this is what we call X. X is the ratio FT over FR. So FT over R2, you have to use the equation. Equation actually from your textbook and in your textbook, textbook on page after your table. Textbook. Be careful to get the ni. We are not alpha 0, guys. Jangan make silly mistake using the first one. This is alpha 0. This is alpha. Look at the question. Alpha is because this is for this one is for radial ball bearing. We are talking about angular. Angular is alpha 25 degrees. So since our ratio F thrust load over radial load is 0.682, so it is in this. Okay, you use this one, angular ball bearing. So since our ratio FT over FR is 0.682, so is here the second is between range 0.68 to 10. Total class, use the equation FE FR then 1.87 ni FT over FR. So we got this is FT over 0.682 minus 0.68. So you got your value of your FE. So already calculate use the this equation 1x. So this one they said ini they are using Mascat, this guy, they already have. So FEX ni is this equation. Then you get A51.74. Dapat kat kelas. So FE tu, because in this textbook this is how you calculate your F equivalent, because you have a ratio thrust load over the load. So this is your FE. So FE is already calculated. They use this second equation this one. So FE is 851.74 Newton. So this one will be your FR class. So this will be your CRQ bearing at E. We are talking bearing at D. Apa saya ni? Bearing at D. Bearing, tadi just now bearing at B and now bearing at D. Radial ball bearing. CRQ is KA. KA is the same value. KA over your ni. FR ni put it here, class. Class, are you watching or not? This will be your FR, class. Are you there? FR is FE replace your FR because we have ratio, we have thrust load, we get the equivalent load. So this one will be your life over KR. KR is the same, life is the same, and we already calculate, and LR is like tiny. So you put into the equation. So then you get KR just now we got KR is 0.35, 98% of KA just now we got moderate shock. KA is 1.1. So you just put the value 1.1. This one is 851. FE replace on 851.74. Then you got your life just now. We got our life is 3 and time to the power of 9. KR is reliability factor is 0.35. See, this one 9 times 10 to the power of 7. So 100 to the power of 0.3. Don't have to put into all the equation there. So we got our CREQ is CREQ bearing at D is so our CREQ at bearing at D, D is angular ball bearing is 5012.351 Newton. Okay, so okay, angular ball bearing, angular bearing. Okay, 5 kilonewton, 5 point is 5.01 kilonewton. So we look at the textbook angular ball bearing. This is for table 14.2, angular ball bearing. Okay, let me erase all this thing. Okay, angular ball bearing kat mana? 5.01. Okay, jangan look at solution lah, kita study lah. Look at my live video. 5.01 angular. Angular mean the middle column, class. Class. Class, are you there? Are you watching or not? Okay, angular ball bearing, because bearing at the angular. So 5.01 the for extra light mana? Cepat sikit. 5.01, the nearest maximum. 6.3 betul lah kan? Okay, ball 45 betul tak? Ball 45. Okay, 6.3 ball 45. Okay, another one. Okay, class, are you watching? Because kita 5.01 kilonewton, so ball 45 for extra light. For medium series, nearest maximum berapa? Class.
Six.
Okay, 6. So this one is 30 for medium series. Sorry, not medium, light series. For medium series is 5.8. 5.8, this one is 20. So itulah dari this one Uria. Okay, 6 and 5.8. So you need straightforward, you know lah. So you bore 45 extra light, bore 45. Extra light is bore 45. You go for extra light. Okay, this one represent ball bearing and angular ball bearing. Extra light ball 45. Extra light ball 45. Extra light ball 45 mana? Extra L start from L ball 45. So L09. Tadi saya put L09. And light series just now ball berapa? Okay, ini tak saya jimat masa tahu kan ini ball 30206 Okay, kelas boleh? Faham Yang salah coding pula. Correct. Apa tu? Okay, ni. Design the suitable ball OD. Ini mana, how do you do this? Design the suitable size of ball. How do you get this thing? Ball OD, WR, PS, DH. Where you get one? Design the suitable size. Refer figure question 1. Okay. Just now, okay, if you look carefully, now you want to select the proper. Tadi just now we have a set kan, where okay, we go for ball bearing. Okay, you said design all bearing B. Okay, bearing at B just now. Okay, we have ball 40, we have ball 20, we have ball 70. Tengok sini, bearing at B ni, diameter of shaft is 30 kan? Class, this is bearing B kan? So we use ball. So we use, that's why we use ball ni. Bearing at B, roller bearing at B. So we use ball mana kita use? We have 40.
20.
but the bore size is 30. Macam mana you nak put bore 20 or bearing to shaft 30? Yeah, you are right. Kita can lace the shaft. You are right. We cannot use, kalau we use bore 40, cannot. This is impossible. The shaft is 30. The shaft cannot be increased. The shaft can be reduced by lacing machine, right? And you are right. So we will use bore 20. Understand that, class? Choose one. Hello, class. That's why we choose the bearing. Okay, 17 also can, but you have to lace more. Tapi if you use bore 17, it means that, okay, this is 30, the shaft has to reduce to be laced to 70, but it will make the shaft weaker when you do fatigue analysis on the shaft, because maybe we have bending load. Remember, the shaft, we have to do fatigue analysis. Remember your project, your project is like, I want you to do bearing first, then you select the bore, then you design the shaft. Then that's much better. But in this case, they do the shaft is already there, that I mentioned. Okay, so the point is we use the most suitable one is 20 again, bore 20. Understand that, class? So bore 20, that's why boring bore 20, bore 20. So bore 20, if you look on the pada figure yang parameter tu ni. Okay, bore 20. So we use bore 20. It means we go to table 14.1, table 14.1, bore 20. Apa tadi bore 20? 204 kan, bore 20 tadi bearing B, bore 20 is this one, bearing at B, bearing at B, roller bearing at B, bore 20. Okay, bore 20, it means light series. Sorry, light series bore 20, light series 204, 204. This one is 204. So 204 ni, if you look on 204, they have all these things. Nampak tak? The bore, the outside diameter. So that's what you're asking, class. Outside diameter is 20. Class, do you understand or not? Class, here. This OD 47. W. So what is that? OD W14 R 1.02 is if you look on the answer, is here this one, OD 47 kan? OD 40. Outside diameter 47. Okay, and W is 14 kan? W is 14. R is 1.02 kan? Then DS and DH. Sorry. DS and DH ni, DS, what is all this parameter ni? This spec ni semua, all this parameter ni is already stated. This is the housing of your, this figure DS, this is the distance. DS will be your shaft shaft yang be added to mount. DS is, this will be your shaft. Your DS2 is, just now is, DS is 25.9. So we just put the ni, clear class, just put the value of here. If it asks in this thing. Class, are you there? And okay, bearing at D is angular ball bearing. Okay, if you look bearing at D, mana bearing D? Okay, here is bearing D. The step here is 22. It is 22, but it's not given. The shaft is a little bit less, about 20 lah, 20 millimeter bearing at D. So that's why we have already bearing at just now bearing at D. We have what do we choose here? If the figure at bearing at D is 22 diameter, so what will you choose here? What is the proper one? Angular ball bearing. Which one?
Bore 20.
Ball? Yeah,
20.
ball 20. Yes, ball 20. Okay, so that answer. So now you choose ball 20. Okay, ball 20 at D. Okay, the smallest ball 20 meter has DS. Okay, ball 20. Ball 20, this is medium series. Medium series 304. 304, so you go for here again. Okay, this one. 304. You have 2052 and this one 2052. Ni be careful. The smallest port is the DS. Remember that the shaft diameter has 22 millimeter. If you use bore 20, hence the smaller bore size is 17. Bearing 2 or 3. No, actually not bore 20. hence the smallest bore size is 17, bearing 203. Use this one, bearing 203, not 304. Sorry, guys. Not 304. Use first we said is 304. But remember the shaft has diameter of 22. The shaft has diameter of 22, and hence the smallest bore size is 70 millimeter. Bearing 203. 3 bearing of 203 are required to support this cube of so this one they use bore 17. This one 203. Why is it 203 for roller bearing? Just now kita discuss about bearing at roller kan? Okay, tadi roller kan, now is angle at D. D is sorry, D is mana the D is D what we get. So which one that we select from here? So it's stated that D is carry 3 points guys. Kalau why does it say 17? We don't have bore 17. Apa judgment dia buat based on this one, bore 17 203? Because kalau if we use 20, bore 20, because this one have 22 millimeter, we have bore 20, 22, 20, so it kind of like 1 millimeter gap of the step. So remember the shaft has 22 diameter, hence the smaller the shaft ni, it means the shaft ni like it's assumed that this bore, this for the bearing is 22 millimeter. Okay, 22 millimeters. Bearing 203. That's okay. Bearing 203. Choose bearing 203 because bearing 203 have bearing 203. Okay. Previous we want to before this we want to use 2 of we use bore 304 kan. Previously we used 304 but it changed to 203. Change to 203. Tak apa, this one lah. Ini ada judgment. You read, study this thing because 203 also 5 kilonewton. 203. So we don't have 203 based on our ni. Tetapi 203 you look and study this thing. Why you make the yang because guys kita I want to discuss for another topic. This one you make really a good judgment on that. You carry 3 points. Alright, apa tu next one, okay class, next one will be on question on BEP. Kak boleh bawa lagi kelas? Boleh kita revision, boleh kalau kelas. Kau nak break ke apa? Kalau break kita boleh break sekejap. Nak break sekejap Kalau kita break for, boleh kita break for 15 minutes? 15 minit break.
Alright, Doctor.
Okay, 15 minit, jumpa balik pukul 9.45 lah kan? 9.45 kita jumpa balik. Okay. Kita break sekejap. All right, class. Are you there, class?
Yes, doctor.
What about the rest of you? Semua ada sini? Kenapa participation low Tak ramai orang kenapa Okay, kelas kita continue Yijian, are you recording? Yijian, are you there? Okay, thank you Yijian. Okay, kita go for question 2 Question 2 about your VBEL Okay, VBEL, okay, in this set of test for VBEL it is pretty straightforward. Okay, pretty straightforward is, okay, remember your Mitsubishi, let me share you your Mitsubishi. Can you see the Mitsubishi class? I'm not sharing Okay, hold on. Hello class. Okay, for this question 2 question 2 on VBEL. VBEL, so okay, you must know procedure if you look on my live video. First thing, when you must HT is for motor motor power this is motor power HT. So with that first step you got to calculate your H design power so your KS service times your HT. Sekarang macam mana, boleh ke? Okay, just hold on, I got to restart my laptop. Hold on. Never mind, I got to restart. Hello, Eugene, are you there? Sekarang okay? Let's go for okay. I share you the okay. Can you see the ni class question 2 bad class. Right. Okay. Normally, if you look live video, you can see first HD is from auto power, and calculate your HD KS times KS, where KS is your KO overload factor plus K idler factor plus K environment. So this one will be your KS, and service factor times your HD is transmitted power from auto. So your HD is much bigger. So the HD, and also from the normally when this case, or this kind of question, our minimum pulley is here on the right. So this is our bigger pulley. Okay. So it's given like this. Okay. You always read the question. So it have the based on result. Okay. All right. We have input. So input, this one will be input. The input minimum shift, minimum pulley input is running counterclockwise direction. So this is driving. This driving. This one driving. Okay. The speed. Tap center distance is already in all the table. Motor capacity 2,000 pound each. Okay, 2,000 pound each, 500. So it means you can 2,000 pound each. It means you can get the power. Okay. Okay, driving. Okay, this is driving RPM, and one is 500 RPM. Okay, 500 RPM, and okay, maximum power. You need to use this motor ni for us. Remember, for us to get the KO overload factor. Okay. Okay, kalau this one is driving, this is also turning. Apa tu? This driving, this is driven. Okay, first we have to find the, okay, if you look, we just part one, belt type. To get the belt type, we need to get the design power. Okay, we need to get the design power. And design power is KS service factor times the HT transmitted. Okay, what about KT? HT is the transmitted power, but in this table is given that, okay, this one you want to drive, okay, our machine is crusher. This one high impact. Crusher is a heavy duty machine. Okay, that was pretty okay. Let's go for this part one belt type. First, for belt type, we need to get the HD and the N1 speed of the minimum shift. Minimum pulley speed is already given is 500 RPM. This one 500 RPM, 500 RPM, and also your HD to calculate the HD. So what is HD? Design power is, as you look at my video, KS times HD. If you look on the Mitsubishi guide, okay, KS service factor. KS is time HD, KS, KO, KI, KB. Okay, what is KO? KO is service correction factor. Service correction factor is you got on the table here, table 11, KO. Are you watching the Mitsubishi in class? Can you see? Class? Class, are you there? Boleh nampak Okay, kalau lain tak inform me kalau apa-apa line tak clear apa. Alright, okay, KO. To get the KO, service correction factor. KO plus KI plus K, that will be your KS. KO service, okay, driven machine is stated that driven machine is kita is a driven machine. Type of driven machine is a crusher. It's a crusher. Crusher ni will be, it crush something like, so will be heavy duty. So we go for to get, okay, crusher is more, this one is more yang low duty. This one low to mid-level duty. This one more on heavy. This one heavy duty. Crusher falling into category row number jaw roll crusher. Nampak kelas Can you see this one? Ada crusher, jaw roll crusher. Crusher machine is a heavy duty machine. Okay, kelas. Okay, are you there? Faham Row number 1, number 2, number 3, yang driven machine is not Yeah, also, hold on. This one also have crusher. Be careful. Are we a jaw roll crusher or we just typical crusher? Which one that we are using? This one also crusher. So crusher, I think better we take this one. Be careful. Do not take the roll. Class, are you there? Faham? Class. Crusher will be your third role. Crusher, you crush heavy duty. Okay, what is our running time? Running time is what? Machine running time. 10 hours per day. So this one, we want to get the what we call KO. KO is a service correction factor. Running time is 8 hours per day. We said that is 10 hours per day. Okay, 10 hours per day. 10 hours per day into which column? Is it this motor or this motor? It's stated that the motor is maximum power less than 300% of rated power. So you will use maximum power less than 300. So we will use this one. Always look in the question and be careful. It's stated maximum power less than 300 of rated power. So we will use this one, the first column. And we use this row. So running time per day is kita 10 hours per day. 10 hours per day, so we go for the middle. This one 8 to 12. So it will become 1.3. So it become 1.3, 1.3, betul tak? KO 1.3, betul guys? KO is 1.3. Our KO is 1.3. KO 1.3. Okay, class, KO 1.3. 1.3 and another one is your punya KI, idler factor. Class, okay. If this one is rotated like this, guys, ini rotated like this, which one is cable yang tight side, which one is the select side? Look at this one, the V is on your right, your minimum pulley on your right is driving. Is driving. Which cable on the tight side? Which cable on the loose slack side? Top low side ke? Top is slack loose. Top is slack or top is tight? Bottom tight or bottom slack? Class, I'm asking you. Class.
Top is slack side.
This is the driving. The minimum pulley on your right is driving. This one will pusing. This one will drive. Bottom belt ni tight or slack? I want to ask you. If this is the case. Yeah.
Tight.
Tight. Tight.
Yeah.
You are right. This is tight side. Okay. Top is slack. Be careful about this guy. Kalau ni tak tahu problem lah. Pasal this one the minimum pulley diameter. This is driving. Bila this is driving, not the bigger one driving, the smaller one driving on your right. It's rotated counterclockwise. It means it's kind of like pulling. It is pulling the bottom. It is not pulling the top. It is pulling the bottom. So the bottom belt will be on your tight side. So the top will be slack side. So in order for us to find the KI, idler factor, because we have an idler here. Okay, our idler here is on the slack or on the tight? Is on the slack side. Correct, guys? Can idler is on the slack side. Okay, idler is outside the slack side or inside the slack side in this case?
Outside.
Yeah, it's outside on the select side. Outside, the idler is outside on the select side. So that's why you use your KI here, table ni. Table idler. Okay, which one? Which one? 1, 2, 3, 4. Apa kita cakap? Belt slack. Location of idler at the belt slack side. Outside of belt. Here, betul tak kelas?
Yes, doctor.
Belt slack side of the, so it will be 0.1 Will be, yeah, 0.1. Okay, 0.1. So KI is 0.1. Itu be careful guys, you kena tahu idler tu you silap. Careful. Tengok which one is driving, turning of the direction of the rotation, clockwise or counterclockwise. Be careful about it. Okay, KE environment is any statement about dusty environment, high temperature, environment condition, dusty environment and exposed to rain. Okay, you might ask me, dusty environment exposed this for your KE. KE. So KE dusty environment 0.2. Exposure to rain. Okay, there are dua condition. Dusty environment, exposure to rain. Which one you want to use? Or we want to add 0.2 plus 0.3 water splashing ni? Exposure to rain lah kan? Betul tak kelas? Dusty environment and exposed to rain. So what would we use for KE in the table? Dusty environment, yes, we have. Is it oil or water splashing, exposure to rain? So my point is, previously student asked me, so they have, okay, the question stated is water splashing, and also they have dusty environment. So what is about our KE? Which one do you want to use? Just select one. Do not add it up 0.2, 0.0. So use one. Understand, class? So use one. Your KE is, I don't know why they put 0.2, 0.2. Okay, that is okay. Put 2. Maybe I have an argument on this. To me, it's just like one. So 0.2 plus 0.2. Tak apa guys, 0.4 lah. Okay? You understand what I'm talking about, right? Tak apa, okay. In my class, kalau you jawab, you pilih 1 pun tak apa. If you add it up, it will become more bigger, you punya power nanti. Sometimes the solution provided by the lecturer pun, sometimes we have argue on this. Class, understand the situation? We have some issue here. Yeah, my opinion, just use one only. But if you have both case, okay, if you add it up, because the question is said, okay, KE, okay, does it state choose one? Other statements in it, what is my cover? Because it's not from textbook. If textbook, they have some written up explaining something. If you have 2 factor, choose one. But this one, we are not sure. If we have both condition, my opinion, just select which one is the worst case lah. Understand what I mean? Understand? Yeah. Yeah, that is my opinion. If I am not, I'm sorry, I just want to make certain if I am not mistaken. I didn't say I am 100% correct. My opinion as engineer, I think select one, choose one. Which one is the worst case? Because when you add it up, macam this lecturer give us, they add it up, okay, they have dusty and they have water. I'm not sure because Mitsubishi is not from textbook. It does not statement. They didn't put any guideline here. Again, they didn't mention. As long maybe I'm wrong. Any statement you point it up to me. Okay, to me, kalau you have both condition, because the equation is just plus environment plus KE, and it doesn't say that. Kalau it said that in this direction, it said something. Kalau you have 2 condition of environment, you add it up. Yes, that's one we are certain. Understand? You agree with me or not, class? Do you agree with me? We take the worst case. To me, it's like that. We take the worst case. For example, your system. Which one is the worst? Katakan this is your project. Which one is the worst case? It's more dusty environment. Yeah, all is 0.2. So you cannot add it up. So maybe this lecturer put add it up. To me, kalau you give 1.2, I make a full point in because my student, I already explained how is it, right? Okay. So just take, okay, let's say lah kita go for 0.2 plus 0 to 0.4. I just look on this. Okay. So we ask our KS is, so now you take note class. Okay, ini we have some issue here. So either we add it up, you have both case. To me, select one. Which one is more obvious lah in your system? Which one is more obvious? Because there is no pointing any direction that you have to add it up. You have 2 conditions. Maybe I'm wrong. I'm not sure. Maybe I'm wrong. I did statement here. I didn't. Okay, as an engineer, you will ask Mitsubishi engineer lah. Kalau if you do your project when you work outside, until when you want to order back, you contact your supplier, Mitsubishi engineer from Japan. Maybe they have here in Malaysia. What is the condition from here? We have to. So the engineer will maybe they will suggest to you. I'm not sure. Maybe I'm wrong. To me, they take some. Maybe their answer take the worst case lah. Which one is more obvious? Is the dusty environment more obvious? Yes, take 0.2. I'm not sure whether, okay, even we have water and raining water splashing, and another 0.2 we add up. So I mean, when you add it up 0.4, so you mean your HD become so much bigger. I don't know, is that accurately or not? Is that correct or not? You make 0.2 plus 0. Itulah saya fleksibel lah, it makes my point. Okay? Kalau you jawab 1 pun saya bagi betul, you tambah 2 pun saya bagi betul. Okay? Pasal kita ada issue on this, okay? Kalau pasal you based on this solution yang ni. Okay, KS is KO, okay, 1.8. So we add up 1.8. So there is 1.8 times the, okay, what is this HT? HT, guys, this is the equation. Kalau they give the power in, take note on this, you give the power that is given is in 2,000 pounds. So how do you get this equation? How do we get this girl? This one from the table at the bottom of your Mitsubishi. Look at, take note on this. This one is very important. Take note on this. If you look on the table, mungkin ada sini. I mean, I'm talking about K environment. Tak ada statement sini. Tak ada kan? Ini just add it up, nampak tak? I don't think so. We have two condition. Tak apa, never mind. Okay, what ni? Power is give in torque, pound inch. Because power is torque times omega W kan. RPM there will be in horsepower. So the equation is here, guys. Take ni. Class, take note on this. Class. Take note on this, Oh, no, sorry, not this one. Okay, this one also you must consider. You must be aware of this table. This one. Power is torque time RPM. This is because you convert your power HT2 to horsepower. Torque in pound inch and so be aware of this table. Everything is there. Macam belt speed also you must be aware. What is belt speed? This smaller pulley diameter, smaller pulley diameter times the pulley speed RPM. This will be your belt speed, tangential velocity of your belt. So power is like this, HT. So this HT is using this expression torque. Okay, so we have torque times NDD. Okay, NDD is we have NDD is just now is 500 RPM. NDD is 500 RPM. So you got a power tadi. You punya HT is you punya torque. Okay, torque time you punya N. You punya N time 63025 from this equation. Okay, you punya torque Q tu it means torque. TQ2 means torque. So we have the torque is 2000 pound inch. Okay, unit is all 2000 pound inch. Be careful. The torque is 2 pound inch, and you punya RPM is 500. You divide by 63025. So you got your two as stated there. Okay, as stated. So you got your punya HT is 15. That is going to be 867 horsepower. Okay, that is HT horsepower. So once we know HT, so our HT is just now. Okay, this one we have issue. Tak apa, we follow this one. So KS time HT. So our KS is now is. So mean the KS ni they added up lah. KS ni 1.3 plus 0.1 plus 0.2 plus 0.2. Tak apa, to me 0.2 is enough. So HT is KS just now, KS to 1.8. 1.8 times your 15.867. So you got your HD is apa PD ni HD lah kan power D HD itu PD PD will be 28.56 H design is 28.56 this horsepower so use this one and your speed okay HD is 28 and your speed of your N2 is 500 RPM this is how you select what belt size lah. So this one will be your certain belt length belt type. This only part 1 baru part 1 belt type. To select belt type based on your ni. So you go for any lah, you go for table. Okay, the first table no. Ni. Okay, this one how you get the table figure 1.1 to get. Okay, since our design power is 28.56 28.56 is somewhere here, 28 here. Bring it up and the speed of our belt is 500. Okay, 500 is here. So 500 here. So ni susah juga ni dekat margin. Which one? You buat carefully lah I think it will be on C lah, not on B Just like border, just margin at B. Are you listening, class? Class, are you there? Are you watching or not? So it will be on B. So the answer they put supposed to be C lah, type of C. And be careful, it's kind of like in the margin, margin between B. Just kalau you buat accurately, 28 is here. And 500 is kind of like still inside C, border to B. Okay, we have okay, type C, so it will be type C. Okay, stated is type C. Right. Okay, type C. Okay, we use type C. Okay, there will be type C. Okay, if you look on the type C, what is the minimum? Okay, it's set. Okay, belt type, type C. Okay, it's already done. Okay, to get the belt length, we need to, okay, it doesn't, be careful. It doesn't say that pulley shift diameter is not given. Be careful, guys. If it's given, use this one, the given pulley diameter, small pulley diameter. But it's not given, so you have to take, it's not given, the pulley diameter is not given. So it means that you have to take, okay, we are using type C. It means so we have to use the minimum pulley type C. For type C, since we have shower HD and we have type C. So the minimum type C, the minimum pulley diameter is 9. Okay. You can take note, table 1.4. So if not stated in the question, is not given the minimum pulley, so you use this one, take the minimum pulley diameter is 9. So in this case, that's why it use, nampak tak, the DD use 9, minimum pulley diameter. Nampak class DD is 9. DD is 9. So you can then we can design. Then you can design your system like this. Okay, kelas sikit lagi. Okay, we have like this. Ni our system like this. Okay, yang ni we just ignore the apa tu idler tu, just ignore it. We already said the KI, we already consider KI idler factor already, and so it means okay, now we have DD is 9 inch. So it's given the center distance initial, yang ni is initial center distance is already given 18 inch. Okay, this one, what is our D? The bigger diameter. The bigger diameter to what is? Because speed ratio, okay, is stated, okay, speed ratio is already 3:1. Apa tak? Speed ratio, speed ratio is 3:1, okay? Is 3 lah, speed ratio is 3, is you punya ratio of your big diameter over your small diameter. Betul lah, kelas speed ratio is... Yeah, 27, that's my point. So this one is 9 inch. So your DD is 27 inch. Okay, that is a speed ratio. That is a speed ratio. Okay, so yang ini DD is 27. Okay. Okay, what about the NDD? What is the speed of the output speed? What is the output speed? Kalau this one is here is 500 RPM again. Okay. Speed ratio ni also is DD over smaller diameter. Okay, is 3. Okay, is also you punya N1 over N2 lah. N1 over N2. So this one will be your N2. This one will be N2. So your N 500 times, so your apa? Speed ratio is 3, right? Ni 166.7 ni in
500 divided by 3.
The speed is 500, right? The speed is 500. So why is it 2? The speed of 2. Ratio the N 500 divided by SR is 3. 500 by 3. Kenapa NDD? Come on, help me. Apa benda yang saya miss ni? Oh ya. Yeah. Saya tepuk kepala saya. Right, kan? 500 divided by 3. I'm talking about 500 divided by 3. 1.6. Okay. Boleh guys? Boleh? Boleh guys, saya dah tua. 500 divided by so you get this one is 3, this one is 500, so this is N2. So you get your N2 is 166.67 RPM. So this is the speed of your punya ni lah, 166.6. Actually, ila depend on the machine macam mana. Alright, that should be your okay. Bed length. We still okay. Now you will ask. Okay, now if you look on this solution, kalau if not mistaken, this solution when they are doing the bed length, they are using this Okay, so our initial center is they are using this equation. Okay, the point is, are we using this equation? Are we, or we use, you might ask me, are we use this equation? Okay, I suggest you guys do this one. Okay, do not use yang ni. Ini is, okay, kalau is, okay, it already stated, if center is predetermined, use the following formula to determine the interim datum length. So ini is another case lah, kalau it mean is already predetermined. You use this equation. Tapi for normally the procedure is like this, right? The step 5, step number 5, you use this LD. Okay, solution we get. Okay, you understand what I'm talking, guys? You that equation instead of dia beza tau, different. Understand tak, class? Class, are you there? For your exam, use this one. Because some lecturer they use this one. Ada dulu, that's another solution. I think the previous year they use this one. Itu yang kind like confusing. Which one? Sometimes they use this. No, you can use this. Tapi kita normal procedure we use this one, LD. Use this one. This one because determine the interim belt data length. So this one the interim belt data length. So because based on 18 inch. So this equation. Tapi the solution here. Okay, I want to save time. Let's say that this is the equation. Take note on this guy. I hope you take note. Okay, we look and say this kind like confusing, right? We have issue. So we actually use this equation. Okay, let's say you use this equation and let's say the value is here 97.049. So we go for the standard length 97. If you look on 97.049, so we go for, okay, we are using C section. C section, be careful, do not select wrong. Okay, this A section, B section, go for C section. Datum length, now outer length, datum length, 97.049, 97, back datum length, 97, back datum length, 97.079. Okay, back datum length, take note. Back datum length ni, kalau 97.07, do not take the closest maximum. No. Back datum length, you can take any either minimum or maximum. Which one is the far nearer? Understand me? 97.09, which one is the minimum? Which one is the nearer one for C section? Plus, are you there? 97.09, which one is closer? 96.9 or 97.9? 97.09 minus 97 berapa? Ya, apa kita tadi? Berapa jawapan? Berapa? 97 sorry. 97. 97.09. So the closest one, yeah, of course lah. But my point is, do not take the nearest maximum. You can take even the minimum. Which one is closest? So in our case here, memanglah 97.09. 97.9 is much. 96.9 dan 97. Which one? Ni nanti tak juga kelas. Tak juga. Cuba deduct 97. Our calculation, okay, let's say we use the equation 97.09. So which one is the nearer? 96.9 or 96.2? Cuba calculator. Which one, class?
96.9 more closer.
96.9 is more closer, more closer. So use ni. Okay, because back length doesn't have to do maximum cap. No. Like bearing, yes, you take the maximum capacity lah, CREQ. Belt is just a standard line. Take the closer one. Sebenarnya tak doesn't harm pun you take the maximum or minimum. Tapi to me, because you don't want your center distance to be so much beza from your initial 18 inch you get. If you go 97.9, dia little bit alter. This one 96.9. Tetapi the solution use 97.9. Not good lah. Not actually not necessary. Not doesn't mean have to be maximum. This one is take 97. Take note, class. Understand tak? Nanti your exam question dia akan cakap back length tu take the closest either maximum minimum. Dia akan mention, dia akan remind you, not necessary to be maximum. Because nanti some of you nanti okay, look on the question. The question nanti will ask you either they ask you take the closest. Dia ada put statement. Understand me? Take note. So jangan, if the question clearly state, the bad line ni, you select bad ni, the nearest one, you didn't say maximum, select the nearest. Macam in case 96.9. I think yang this one, the old solution, they use 97. Okay, let's say this one is 97.9. So use belt code C95 lah, 97.9. So belt code ni, dia, let's say lah, we use 97 C95. Okay, belt code C95. So we will order this belt lah. Tetapi we order this belt, but we must make sure what is the number of belt we need. We ask the Mitsubishi company, you send email, you ni require to order this belt. Belt code 95 C section, C95. That's what I said, C95. C95. Then they know lah, this is 97.9. The Mitsubishi people will know. But they will ask you how many number of belt do we need. That's why we need number of belt. So number of belt is our design power over kita punya HC. HC. Okay. HC. So that's why you punya ni center to center. Okay, sorry guys. Yang ni, okay, belt length, sorry. Before that, center to center distance. Okay, center to center distance you have to, because kita use 97.9. Okay, since we use 97.9, so our center distance ni adjusted lah. So center distance before this, this is part 2 question. Center distance is B plus, okay, use this equation, B square minus 8, bigger diameter minus smaller diameter square over 8. So what is B already there? I hope you understand. B is 2 length. Okay, nampak tak? B is 2 length D. This D is the standard length, 97.9. Okay, tadi we have an issue, doesn't have to be maximum. I hear you take note for your test, guys. Take the closest one. Doesn't have to be maximum. The either minimum, which one of course. It's supposed to me, and this one is supposed to be 96.9, not 97.9. Okay, tapi okay dah, tak apa. Kita ni 97.9. Okay, this is 97.9. 2 kali 97.9 minus pi over bigger diameter. Bigger diameter we already get it kan. Bigger diameter is 27 inch and smaller diameter is 9 inches now. This is 27 inch, this is 9 inch, this is square. And so you got your B, B substitute into here. This one bigger diameter. So you got your C. So there you have your C value. So you have your C value. Okay, the C ni, okay, already calculate. The C is 18.485. I mean your center distance to the increase. The increase it will be 18.485. Okay, 18.485. So that will be your part 2. Dan kemudian number 4, determine the required number of belt. So number of belt, okay, you order C95 kan, C95 C type C, 95 is the code number. Okay, C95. So what is the number of belt? The Mitsubishi will ask you how many belt that you want. So you have to calculate. So this is on your design power over your HC. HC ni, if you look from the apa tu, HC is a corrected power rating. This is your design power just now we already calculate. Okay, our design power just now is 38.56 28.56 horsepower. This one is 28.56 horsepower. This one is power. Okay, power per belt. So we have to look on this C95 just now, the C section, that belt yang we select tadi. So that belt, for one belt, that one unit, that belt that we select just now, how many power it can carry? One belt. So this is total power we want to carry 28%. This is the point, the number of belt. Okay. So the HC is corrected power rating per belt. So we get the number of belt. So HC is your HS is your basic. This one corrected. This one basic plus additional. Basic power rating plus additional and times your KC. KC is another factor. KC is what we call power rating correction factor. KC is K theta times KL. K theta is angle of rep correction factor. L is the length that you choose is not 97 point correction factor. So KC, so we calculate first our HS, basic power rating you can get from table for this table at the back for basic power rating per belt. Okay, this one is basic C section. Okay, this one is B. This one is, so we go for C since we use C, basic power rating per belt. So so we have here small pulley RPM. So remember we use 500 for small pulley RPM. Okay, this here. If not the pulley is need, you must use interpolation. Class. Class, you listening or not, class? Class, are you there?
Yes, Doctor.
Class. Okay, 500 RPM use kalau no is let's say 550 you have to use interpolation. You know how to use interpolation to get it. Okay, 500 RPM. Okay, what is smaller pulley diameter in inch? Our small pulley diameter is in inch is 9 inch. Okay, 9 inch is here, since it's here, so 7.6. So this will be our HS is 7.6. Okay, so HS is 7.6. Okay, already 7.6. And additional is here. Okay, our speed ratio, remember 3, greater than 3, this line. So 0.74 is HA. Okay, 0.74 is HA. So, okay, this SS is 7.6. Jadi adalah 0.4. Okay, this one 0.4 HA. Okay, now is about KC. KC is K theta times KL. K theta times. So, kita punya K theta just now. K theta is from here. K theta is angle of wrap. You can bigger pulley diameter to get K theta is angle of wrap. Okay, we have 27 minus 9 over center distance. The new center distance just now. The new center distance is our new center distance to adalah 18.485. 18.485. This one 18.485. 27 minus 9 over 18. So you get that ratio. So you get the ratio, so it will be already stated here. The ratio is 0.974. So you get 0.974. 0.974, it will go for 0.974. Table 1.6, it said K theta is 0.82. 0.9 said the K theta is from table 1. Table 1.6, K theta 0.82. Ini 0.974. Kenapa 0.82? Yeah, it's close to 1. Close to 1. Because 0.974 is close to 1, so 0.82. So that's why you use 0.82. Take note, class, faham? 0.82. So you punya K theta is 0.82. So this one, the length factor. The length, remember the length that we choose just now, our length, the standard length we use is 97.9. C section. 97.9 is within this 96 here ni, 96 to 104. So this one will be 0.1. Class understand? So KL is 0.91. Okay, as stated here, this one is 0.91. So KCC, K theta, so we got 0.76. KC is 0, K theta times KL, so we got 0.746. So this one, okay, so your HC, your HC is, so your HS plus is equal to 7.6 plus 0.4 times 0.746. So you got your HC is, HC, PC ni HC lah, so 6.223. So this is the horsepower, this C section just now that we select, the C belt yang 97.9 the length, standard length, it can carry 6.233 horsepower. So we divide, so it means that a number of belt, the design of power 28.56 divided by per belt, okay, per belt is 6.223. So number of belt is 4.589. Okay, this number of belt, do not take this one, take the nearest, this one, the nearest maximum. Kalau saya punya number of belt, just in case, 4.02. What is the number of belt? Just number of belt is berapa?
5.
Yeah, 5. You are right. Understand that? Even 0.02 as engineer, because 4 is the, if you take 4, your belt will not save. Even 4.0 something also is even is bigger than 4.0, take 5. Okay. Macam ni 4.5 in, so number of belt is 5. Okay. So number of belt will be 5. Okay. Okay. This one, you must know also, sometimes they ask you about, okay, this one is not asking, you know how to calculate this one, the angle of wrap, okay? If you're not, in the question they ask you, okay, this your belt like this, kelas tengok. Kalau kita extend masa, sekarang dah 10.30 kan, saya terlebih sikit mengajar boleh ke untuk kita gear tak masuk lagi? The angle of wrap, kalau this small pulley, angle of wrap yang ni angle of wrap, yang ni they are right angle with your tangent lah. This small pulley is bigger angle wrap, bigger because it is tangent to your center. This is right angle, this is right angle. The angle of wrap or bigger pulley is little bit smaller. This is sigma capital D, sigma angle of wrap. Sometimes they ask you, because angle of wrap, yes, important for your shaft analysis. Your shaft nanti you have cos of this angle. Tapi you don't have to find this theta lah, this angle of wrap. Angle of wrap, you use this one. For small pulley, this small pulley, theta D, this one, this question. Sometimes they will ask you, 180, this all in degree. No, this not radian, guys. Inverse sine, bigger pulley, diameter minus smaller pulley over your 2C. This one 37, this one 9 inch, 2C, center distance yang baru tadi, 18 point something, kan? This is your center distance that you adjusted. Not 18 inch, kan? Tadi 18.4, tadi berapa? That the new center distance, So you got 10 degrees. Then what is the bigger? If you ask you about the bigger is just a plus. Sorry guys, saya ni silap ni. Big angle of wrap or bigger is here. Bigger is plus. Bigger is much greater. My mistake, right? Okay, bigger pulley is much better, much bigger. This one is plus. For bigger pulley, on large pulley 180 plus. The only difference is plus minus 1, DD minus DD over 2C. Okay, 31 minus over 80, berapa tadi? 18.4 something. Okay, bigger pulley diameter is here. This is the angle of. This is a wrap angle, not here, guys. So, bigger, large pulley is this is the angle. Small pulley, this is angle, small. So, that's why they minus. Okay, this one, kalau ask, this is question, you must take note on this, be aware. Okay, it asks about minimum tension. Okay, minimum static tension. Okay, tension side, tight side. You know how to get that one? Tight side, this table. Table yang the last table though. Okay, the last table though. Class, are you there? Hello, class, are you listening or not? Class, right? The tight side is 33,000. Okay, this is a tight side. So you calculate. 33,000 times HD. HD, just now we got HD tadi berapa? HD is 28.56 kan? We already know 24 horsepower. Okay, what about this B? Okay, number of belt ni bukan 4.589 kan? Number of belt is the angka bulat near the maximum 5. Understand class? Jangan take yang 4.589, it's totally wrong guys. 5 Number of belt is number of belt. 5 5. So this one, what are V? V is the pitch line velocity of the belt. P, okay, this is a belt speed. Belt speed is DD times ND times 3 over 3. ND is so your belt speed here, belt speed. So what is V? So because like this guy, so this is your small pulley, the bigger large pulley, this is a small pulley. So this is, actually your pulley is rotated 500 RPM. Okay, RPM. So this is your N1 500. So the tangential is what you call tangential velocity, V. Along the web, this is a tangential velocity is the same. When you wrap here, same tangential velocity. Remember basic physics, tangential velocity is R times W. The radius here times the W of it. Radius of small pulley times the W of small pulley. So this is the question is V is DD times your ND, your small pulley speed in RPM over 3.82. So you get in feet per minute. So small pulley is 9 inch times 500 RPM over 3.82. So you got your V is, okay, V already there. You got your V is 1178.01. Ini feet per minute. Already they done the conversion unit. Look on the tables now. Feet per minute. Okay. So that will be your V. Okay. In our equation also, we have for tight side, we have here. K theta, you know, just now K theta already find K theta, right? K theta, the angle. K theta is 0.82 angle of wrap vector. W, okay, what is about? We have W, okay, V is just now tadi 1178.01. What about W? W is your belt per unit meter weight in kilogram. That is W is here, and W is here. So it means since we use C section, this table, guys, take note, we use C section, kan? Okay, this C section, we use one. W is kilogram. It means your belt, the C section belt yang you select is now 1 meter. What is the weight in kilogram? So it's 0.3 kilogram. Okay, so the value of C is 0.3. You just put it here. You just put it your W, unit belt per unit weight length, belt per unit weight. 1 meter was the belt weight in kilogram. You just put that in value in kilogram. So here kilogram. So V just now we know times. So you got your tension side. So that's why tension side already calculated. 2 for 1 pound force. What about loose side? Loose side is this one. Select side. Select side is this equation TS. The only difference HD, the number of belt is 5. B is the same. And then the only difference is 2.5 minus 2 times K theta. K theta just now we get and get off right 0.82. W tadi just now we already got it, kan? Okay, W 0.3 and W and times all this equation. This loose side, this one tight side. Take note on this, guys. So the loose side, this one the minimum static tight side TO and tight side TT. TO. Okay, ni minimum static tension. Minimum static tension ni. This one guy, that's not loose side. Be careful. You said about determine the minimum. This is not select side. Static tension. I mean, while the pulley is not rotating, it's at static. What is tension? Sometimes they ask you, be careful about this. Not select side. Tight side already calculate. Static tension is here, guy. Static tension TO. Be careful. Read the question. If you ask you select side, tight side, you use the equation. Static tension is 0.9 times TT. We already calculate our TT. So now put your TT here. Plus that we need to get the select side. Select side is here. Select side is equation. So we have to find both, put into 0.9 reduce static tension. That's why they will do it. So they have to calculate static tension. That's the formula. TT is the tight side. TS is the select side divided by 2. Or this one. Or this one. Tak payah pun you use this one. That's why they use this one. Ni already they done it. You don't have to calculate for select side in this case. Use the equation 2.5 K theta. Everything is there. Just substitute into this equation. Okay, they use this equation. Kelas faham apa saya kat ni kelas? Boleh kelas? Are you there?
Yes, doctor.
Okay. Okay. Then if all remain the same, but driving pulley with the belt lap get stronger. Ini you have to judge lah 3 marks. Sometimes they have last question will test your IQ. If all conditions remain the same, all conditions, but the driving pulley rotate in a position. This one rotate different direction. Will the belt get shortened, longer, or remain the same? Ni you kena fikir. Apa yang berubah? If rotate different, apa yang berubah? Apa yang berubah? So, saya tak ada masa nak explain about this thing. Pasal kita already ni, if all conditions remain the same, but the driving rotate, will the back rotate, it will shorten the backlash since extra tension load are given on the tight side. Okay, betul. Because kalau this one rotate this direction, yes, this become tight. Then ideally is become more tighter. Nampak tak class? If this rotate, okay, initially this one rotate counterclockwise, but it say the reverse direction. Okay, this is a good question test. If it rotate this clockwise direction, the top belt become tight, but it worsened by this idler. Idler press it lagi, become tighter, so it will shorten the life. Understand?
Yes, doctor.
Alright. Okay, boleh tak kita go for gear? Okay, sekarang kita go for gear. Okay, gear is alright, gear. You look, boleh tak you look on this? Kita already gear normally what is the gear most critical? Okay, for example, we have this set of gear. They have a set. Okay, they have a seat. Okay, gear 2 and gear. Okay, they have a system. Okay, the input is gear 2 here. And this one gear 3. Gear 2 and gear 3 have the same T's, 30 and 30. 30 and 30. Gear 4 is gear N5 equal to N4. So I mean N5 is already given. They already given. Gear 2 and gear 3. Okay, gear 5 has the same diameter as gear. Okay, calculate the diameter of gear 5 and the tension for the act on the gear. Which, alright, apa ni dia? Okay. They have the system 300 RPM, okay, 300 RPM. Gear 2, 3, they give the gear teeth is 30. Okay, and the two idler gear, gear 3, two idler gear. Gear 3 is idler, gear 4 also idler because in the middle, gear 3 means they have load here and they have load. That's idler. Gear 4 also they have load here and they have load here. That's idler gear. Okay, and between gear 2 and gear 4. Okay, shaft D will drive heavy shock. I mean, shaft D, the 5 output will drive heavy, heavy shock machinery. The number of teeth of gear 2 are 30. Okay, the pitch, okay, P is now, P is per inch is 6, okay, per inch. Pitch width, B is 1 inch, okay, B is 1 inch, okay, and the pressure angle, you punya pressure angle, P is 20 degree, okay, we use 20 degree pressure angle. Okay, okay, the gear, okay, sekarang we look, the number of teeth of this one, actually you can get it, tapi look on the first question. Which gear is the most critical? Which one is the most critical in this case, class? Okay, in this case, yang critical, critical is, which one is critical? The critical is supposed to be gear 3 because why? Again, they have two loading. If you look on gear 3, okay, if you look on my live video, okay, gear 2 is smaller. Actually, smaller gear is critical. Smaller, okay, is rotated like this. So this is gear 2. Gear 2 have, so it means reaction from gear 3 to 2 is like this. And here like this is your gear 2. And also you have reaction on the shaft lah. And also in the top, okay? This is gear 2. This is gear 2. Gear 3, if you look gear 3, I made it up here. So your gear 3, small gear, it have suffer both. You have, okay, this one is to right. Okay, here the gear from gear 2, F tangent from gear 2 to 3. This is my F tangent. This one F radius. F radius 3 to yang gear. Well, my point is because gear, okay, I draw my gear 3 here. Gear 3 is same. Gear 3, it have F radius to 3. Okay, F radius to 3 and F tangent is like this. F tangent to 3. And also it have from gear 4 also, because this is rotated like this. So rotate like this, then it will rotate like this. And it have reaction from gear 4 like this. Gear 4, reaction from gear 4. This one, they have F tangent 4 to 3 and it have F radius 4 to 3. So gear 3 is the worst case because since it's a small gear and it have two, I mean each tooth on gear 3 suffer 2 times punya ni. Once at from gear 2, gear 3, this is gear 3. Okay, gear 3 is the critical because the most critical because it have reaction from gear 2 and also at gear 4. Okay, gear 4 since it is bigger, so actually is a it's not suffer because of the, you remember the equation of bending stress. So gear 3 is the most critical. That's the answer. Okay, calculate the diameter of gear 5 and the force that acts on the gear. Gear 5, you can calculate it based on the ratio. If you look on the solution of your gear, okay, already it's given N3 and gear 2, gear 3, we know the number of teeth. And for since it's given, okay, from this question, N4, okay, gear 4, gear 5 must, because since the diameter is the same, the number of teeth is same, so the diameter of gear 4 is same as gear 5, and the speed of gear 5 100. Gear 4 also, N4 is also 100 lah, because the same diameter. Okay, 100 RPM. Okay, gear 4 is 100 RPM. The question asks you is that calculate the diameter of gear 5. So the solution is like this. Yeah, the solution is N4 is also 100. So E is N3 over N4. E is N3 over N4. If you look this one, E is N3 over N4. And this one is 300 RPM. This rotate like this. Gear 3 also rotates because the diameter is the same, number of teeth the same. This one also 300 RPM. N3 is 300 RPM. So we know E is this one. E is N3 over N4. This is your speed train N3. drive over driving, driving over driven is N4. Okay, N4. P is N3 over N4. So you can get the diameter of gear 4 and you can get the diameter of gear 3. Okay, so the diameter of gear 3 is N3 over P. So diameter of gear 3 is 5, you can get, and N4 is N3 over. Actually, guys, there is kind like this equation, you get the because this is gear 3. This is your gear 4. Gear 3 like this. This is your gear 3. This is your gear 4. Gear 3 and 3 is 300 RPM. Okay, and 3 is 30. Also 30. Okay, gear 4 rotate like this. Okay, we know, but what is the diameter of, so we know diameter of pitch is 6. P is 6, P is 6. Okay, what is the speed of this? We know the speed kan, E is apa tu, N3 over N4 kan, So we know the speed here is 100, The speed is 100. The speed is 100. So that's why in solution they put it E is N3 over N4 is 3 lah. Okay, N3, N4, N3 over N4 is 3. So it is 3. N3 because N4 is 100, this is 300. So your punya E is 3. So your E is 3. So it means your diameter, that because you punya diameter, because P is gear 3 over diameter gear 3, number of teeth of gear 3 over diameter 3, and we know P is 6, and we know that apa tu, so you punya apa tu, and from here we can get our N4. So the 3 is 6 and 3 over P, okay, and 3 over P, and 3 over diameter 3, diameter 3 is diameter N3, 6 is, N3 is N3 is 30 over diameter 3. So we can get the diameter of this one, diameter gear 3 we can get. So D3 is 5 inch. 5 inch. So your diameter 4, because the question asks you what is the diameter of, calculate the diameter of gear 5 kan, calculate the diameter of gear 5. So you punya gear 4 ni is, we know diameter 6 also and 4 over diameter 4, and 4 over diameter 4. And N4 to is N4 because E is 3, E is 3 and 3. So because this one is 30, speed ratio is 3. So you mean you punya D is number of teeth 3, speed ratio of 3. So it means kalau ini number of teeth 30, so N4 here is 90 lah. Logically N4 is 90 because speed ratio is 3. So you punya, so diameter 4 is your N4 is, so 6 is N4 over diameter 4, and N4 is 90. Okay, so 90 over D4 is 6. So the diameter 4 is 90 over 6. Diameter 4 is 15. Okay, diameter 4 15. So it means diameter 5 also 15 inch. Okay, after 50 inch. So because it's the same, diameter, number of teeth is the same. They say that gear 4 and gear 5 have the same diameter. Gear 4 and gear 5 is the same diameter. Okay, this one I hope you understand. The diameter gear 5 and the tangent force that acts on the gear. Okay, tangent force that acting on the gear 5. Okay, tangential force that acting on the gear 5 is like this class. So you have gear 4 rotating like this. This one rotate like this. Gear 4 and so your gear 5. I mean this is your gear 4. I'm talking about, okay. So yang ini rotate like this. So gear 4 rotating like this. So on your gear 5, so this is your F tangent 4 to 5. This is F radius 4 to 5. So what is the value of this one? So they ask you what is the, calculate the and then the tangent force that acts on the gear. So we have to, tangential velocity is, okay, tangential velocity is same for all gears. Since yes, it's the same lah. Since diameter force, tangential velocity, you're asking about the tangential, sorry guys, tangential force. Tangential force yang ni solution is apa benda ni? Okay, tangential velocity is same for all gears. So we have equations ini guys. Because y is the same. Kalau if you look on the free body, dia sama saja tangential force kan. Kalau you buat from here, you have here, okay, you have yang ni. This gear 4 and this your gear 5. Dia sama saja kalau this one pusing like this kan. This one pusing like this. Tangential velocity semua sama This one pusing like this. Tangential velocity ni dengan tangential velocity is all the same Since you punya, so you can get this thing lah. Guys, terpaksa saya masa limited. Boleh guys? Is it little bit? Sikit lagi. Boleh class? Is it okay? Class, are you there or not? Faham Okay, you study this ini. So tangential velocity is the same. Tangential velocity is same for all gears. So FT ni is still ni, because we know from power kan, we can use the equation from the apa tu, H input kan V3 over kan power kan is kan we know is power kan, power input equal to apa tu FT times velocity over 33,000. Okay, since the tangential velocity is all the same for gear, you can get F tangent you can get F tangent. F tangent, once you know F tangent, so you can get F tangent is 84 point because on gear 5 too, the F tangent too is because the question asks you only about the F tangent only. Calculate the tangent force that acts on all gears, F tangent. F tangent is the same for all gears because the V is the same. Okay, kalau you buat analysis kan, tangential F tangent too same for all gears. It's the same for all gears. Okay, calculate the bending stress. Okay, the bending stress, what is the question for bending stress? Bending stress equation macam mana? Bending stress, okay, calculate the bending stress of gear 3. Okay, gear 3 punya bending stress. Okay, we know the bending stress equation, sigma bending equal to F tangent times diametrical pitch over B phase width, J is per gear geometry factor, KV, KO, KM, mounting factor. Okay, sigma F tangent we already know tadi. F tangent already calculate. F tangent already there. We calculate just now. F tangent we know that F tangent is 84.034 pound force. This one pound force. So what about P? P is just now berapa tadi? P is 6. P is 6 per inch. Okay, we know P is no. What B? B is 1 inch. B is 1 inch. Okay, B is no. What about J? Okay, J is 25-degree angle. P 25-degree angle. If you look from your textbook, under chapter gear class, boleh kita little bit extend masa sikit. So we don't have class on Thursday. Boleh class? Is okay? Class? Okay, 15 on gear 2 strength. Okay, gear 2 strength. Okay, what about J? J is, we use this one. ECMA, based on ECMA application, sigma bending. Okay, sigma bending, FTP, KV, KO, KM. So what is about J? How to get a J? J, remember the question ni, J ni adalah P 20 degree. If we look on the J, okay, we do not use bottom one. Bottom one is 25 degree. Use the upper ni, the top graph ni, 20 degree. Okay, sometimes is it load sharing now? The typical case is no sharing. Unless it's stated. Unless it's stated is load sharing. It's stated. Does it stated any type load sharing? Ada tak? Yes, ambil cover steel. Does not use shaping caster. Tak ada mention langsung about load sharing. So the J value. Okay, the J value is okay. Okay, calculate the bending stress of gear 3. Gear 3 means gear 3 is number of teeth gear 3. Okay, gear 3 ni apa tu, the gear 3 they have, okay, gear 3 ni dia punya condition like this guys. Dia sama aja, FT sama lah. This is from F tangent 2 to 3 and F radius 2 to 3. Gear 3 ni adalah dia don't have reaction on the shaft at the center. And also it have, since gear 3 is rotating like this is rotating. So this one is from, okay, this is F tangent 4 to 3. And this one is F radius 4 to 3. So F tangent is the same. F to 3 equal to F 4 3. Okay, it's the same. Because bending stress, we focus on F tangent. F tangent we already calculate 84.034.4. So this is gear 3. We are talking about gear 3. So what is the bending stress of these two? We focus on just F tangent. So F tangent already there. So J I'm talking the gear 3 is the N is somewhere, N3 is 30, same as gear 2, 30 T. So 30 T, so it means that you go for this one. Okay, 20 degree, 30 T. So you draw ni 30 T. Okay, it doesn't share any sharing, so no sharing. So we nearly 0.2 ni lah, 0.25, 0.3 is 0.26 lah, 0.26. You punya J,
Question
Yeah.
got mentioned is log sharing,
mana?
part 3.
Sorry lah, saya assume share, sorry guys, saya nak cepat, saya tak baca. Be careful, jangan don't become like me. Thank you very much, you very, apa ni, specific, betul, you kena be, don't become like me. Saya pasal nak kejar masa, I thought you guys have class at 11. Assume sharing load, be careful. Thank you for pointing it out. Okay, my mistake. Assume sharing load. I thought it's not mentioned. If not mentioned, no. Sharing load, sorry sharing load, so it means, okay, kalau sharing load, it means you have to use the upper graph, not the bottom graph. So what is your mating gear? Okay, gear 3 we have both. One is mating on the pinion, gear 2 is also 30. One other mating on the gear 4 is 90. Gear 4 is 90 T. So which one? Gear 4 is 90 and gear 4 T. So which one do you want to use? 90 or 30? So we will use, so thank you for pointing it out. So number of T, so this is our gear 3 number of T. So this one is a mating. So mating, kalau we use gear 3 mating dengan gear 2, we use 30. So 30, this is a mating to number 35, 25. So it's between here. So here is about 0.37. So the solution is you punya J. The J is 0.395. Okay, sharing load. Okay, 0.395. Okay. J is 0.395. Yang ini 0.395. Kalau if I take 90 is somewhere here. So I said, which one? Do you want to take 30 or do you want to take 90? 90 is somewhere here. So I think better you go for bigger lah. Bigger. Pasal bigger is, sharing dengan bigger is the worst case. Because if you use dengan smaller, because kita ada both case. Gear 3 ni, Gear 3 is sharing dengan Gear 2 also. Gear 2, but Gear 2 for the J value is lower, 0.3. So this one is not critical. But Gear 3 also sharing with 90. This one N4 ni is 90. We already got it again, 90, because field ratio is 3. It is 90. So we take the worst case. The worst case. So the worst case, it means kita take the 90. So it's much bigger you punya J. 90 is here. This is a 90. Is somewhere here. So it will be somewhere here, intersect. This one is close to 0.4 lah. So that's why I stated 0.395. Macam mana dia punya exactly, saya tak sure lah. 0.4 lah lebih kurang. 0.395. Okay, dia close lah. Dia close, kalau saya erase. This is 85 kan. 85 to consider 90 close. Dia macam up to little bit. So 0.395, 0.395. Clear Clear class this one? Clear or not?
Yes.
Yeah, thanks for pointing it out. Saya tak, I'm catching time, sorry lah. Sharing load. Saya ni nak cepat ni, sorry. Sharing load. Read the question, correct? Assume sharing load. Nanti because always read sharing load. Yes, you are right. So 0.395 will be on. So you punya J ni is 0.395. Thank you for telling us. So J is 0.395. So you already got, KV I think is given, right? KV you have to find, or is it given? Sometimes it's given. KV, KM is given. KV tak given. KV you have to find your own. So you have to calculate for KV. If the mounting km is 2.2. So what about KV? Okay, KV is, so you know how to find KV. KV based on the you punya graph ni. KV. So it stated that, okay, dia cakap the gear is, the way how to manufacture the gear teeth. The gear teeth mana dia cakap tadi? The gear teeth carbon steel being hopped using shaping cutter. Being hopped using shaping cutter. So hop shaping cutter. Nampak this guy? Ni. Hop class this word. Class, are you there?
Yes, Doctor.
Okay, ini line D or line C?
Line D.
D or C? D kan? This one ni D. Hop shaping cutter D. So D lah. D. Mana D? This equation 1200. So you to get KV is 1200 plus B. What is the pitch line velocity? For gear 3, pitch line velocity berapa? Pitch line velocity of you punya ni berapa? What is your pitch line velocity? B apa? V is pi D diameter 3 and 3 over 60, right? Class, are you watching my live video? V pi D3. Oh, sorry. 12, 12, okay, sorry. What 12, Is pi diameter 3 berapa?
Pi.
Diameter 3 tadi berapa?
Pi.
5 inch, yes, 5 inch times 5 and 3, 300, right? Over 12, So you got your V. Mana V dia? Sekarang saya tak nak cepat lagi, put over 12. This is English. Why the n over 12? So we got V is 392.699 feet per minute. So this will be your V. So then you put into the question KO pun tak bagi kan? KO tak bagi kan? Overload factor. KO is not given kan? Macam KM only given, so KO kena cari. So KO you have to find KO. So where is KO? Okay, overload factor uniform. Be careful lah dia cakap the machine medium shock motor. Be careful, medium shock motor. Mana? Are you watching table 15.1 class? Are you watching? Medium source of power. Source of power motor, medium shock. Yes, medium shock. So driven apa machine you want to driven? Heavy shock machinery type. To drive a heavy shock machinery type. Heavy shock machinery type. Ini third column, heavy shock. Betul tak? Driven heavy shock. Source of motor, medium shock motor, because stated medium shock motor. Source of power, medium shock motor. Driven machinery, heavy shock machinery. So heavy shock, medium shock, so 2.25. Betul tak? 2.25. Tu KO 2.25. Betul kan? Okay. KO is 2.25. So you just put value lah. KO, what do you know? KO is 2.25. KM dia dah given. Mounting factor ni kalau tak given guys, this one dah given. KM is 2.2. So this one 2.2. This one KV just now is, KV kita belum calculate. So what is KV? So KV is tadi we use the equation apa tadi? KV we use this one 1200 plus B. V is 392.699 over 1200. So your KV is given berapa? KV tu 1000. KV is 1.327. So you put your KV into this equation FT times P. So you got your sigma bending is this one will be in PSI 8386.213. This one PSI. Okay, remember your SN. Okay, because safety factor, he asking about your safety factor. Okay, safety factor is calculate the bending stress. Okay, just that's it lah. Already calculate bending stress. Determine determine whether gear 3 this one safety factor lah. Part 4. You know SN, because safety factor equal to SN over your sigma bending stress. Sigma SN over sigma bending. So SN, what is SN? Semua benda ni calculate. Your SN is CL, CG, CS, KT, KR, KMS time SI double prime. Okay, SM double prime for gear 2, sometimes kalau they give, because gear 2 is always steel material, if give SUT value, you have to find from the table SUT. So SN is 0 for steel, 0.5 FHK, but it given the hardness is given in BHN, your S prime is your BHN over 4. Understand? SN prime is a standard RR more for bending lah. Okay, over 4. Kalau Balina hardness, this will be your SM prime. So this one is already given the 156 Balina hardness. So SN is 156 over 4. So SN is apa dia? Tak payahlah, dia ni dah bagi 4 kan. Apa SUT? Kenapa dia nak times lagi dengan SUT? 156 divide by 4 berapa?
39. 39.
Terus je lah kan 39 kan? 1000 kan? PSI kan?
Ya.
Tak payahlah, ini tak payahnya, I don't know why. Tak payahlah SUT lagi. Dia dah bagi BHN dan dia turun di 39. BHN over 4 Okay, so load factor bending. Bending always for, because on gear tooth, bending is always gear the tooth bending Bending is always kita based on tadi ni gear pusing macam ni, gear 3 pusing macam ni. Yang kita pasal case gear 4 tadi okay, gear 4 pusing macam ni. So ni the tooth of your gear 4. Okay, direction from F tangent 43. Kita fokus on F tangent 43. So they always happen. Be careful Okay, yang ni always bending. Bending CL is 1 I hope you know. Bending CL always 1 because there's no the focus on bending. Because the equation, okay, CL is 1. Okay, CL is 1. CG, okay, the gradient factor, size factor. Size factor in the notes already there. In the notes, okay, if you look on the notes, chapter 15 on, even in your PowerPoint slide point, the for SL, CL, apa tu ini, okay, CL load factor, kalau diameter pitch greater than 5, use 1. Is less than 5, 0.85. So our diametrical pitch just now is berapa? Diametrical pitch is 6. Diametrical pitch is 6, is greater than 5, so CG will be 1. Because kita punya P is 6, okay? 6 per inch. What about CS? Okay, CS is surface vector. Okay, CS you have to be careful. Take this one. On the chapter 8. Chapter 8. Okay, chapter 8, page 298. Okay, because gear is always, okay, dia gear ni hop use shaping caster. Kalau dia cakap grind, polish, you must be careful about. Okay, just you hop using shaping cutter. Normally gear ni always is machine. It's a machine. Hobbing is a machine process. So we use machine. So we use our BHN. BHN of our gear just now is 156. BHN. So use the top one. The top one is hardness. BHN 156 is somewhere here. 120, 140, 120 plus 120 is 40. It is 140 is in the middle. Kita one apa tadi? 156 somewhere here. 156. Okay, 146. Intercept with machine. Okay, gear ni. Line is machine. This is hobbing machine. So 0.78 lah. Your punya CS must be 0.78. First pointing your CS is. Yep. Understand class PG is 1, 0.78. Class, are you there? Boleh tak? Sikit je lagi. Boleh class?
Yes, sir.
Because kita don't have on Thursday, just to cover 0.78. Okay, CS is 0.78. Okay. Because unless, be careful, kalau it said ada grind, be careful guys, just take note. Fine ground, commercial policy is stated in the question, be careful about it. So you use this upper line. Okay, be careful. Kalau it's not just a hobbing, normally it's a hobbing process. Apa dia CS? Okay, now after CS 0.78, CS is 0.78. Then your KT is temperature factor. Temperature factor, if you go back in the chapter 15, okay, if you go back to chapter 15 for temperature factor, KT. Okay, temperature factor, kalau not stated, KR, KT temperature, KT is 1. Kalau stated is greater than 150, use this question. So it doesn't say anything about temperature, so KT is 1. So KT value is 1. KT is 1. Okay, so your KT here is 1 because we just, kalau it's stated, kalau use KT is 1. If temperature less 100, normally it's 100 centigrade. Sometimes there are hot temperature greater than 100 centigrade, so you must use the equation. Put your temperature here. Temperature is given. So KT is 1. Okay, KT is 1. What is what KR? Reliability factor. Reliability factor is from okay, reliability factor is here, guys. Reliability factor is here. The reliability is mana reliability? Percent reliability? Is it, ada tak bagi kan? Ada bagi reliability how many percent, ada tak? Kalau tak, the value is 1, tu je. Ada? Ada mention anything about reliability? 100% reliability, rate of failure 10%, 90% reliability, tak ada Does it mention? Don't be like me guys, saya ni nak cepat je. You guys have to be read macam betul you pointing out, but read the question, assume, sharing, look, be careful Tak ada kan? Kalau tak ada is 1 so KR my mistake guys. Kalau 90, kalau normally, okay, reliability factor means reliability factor dia ada mention tak 90%? Yes, any Yichin, you nak cakap apa tadi?
The question didn't mention about the reality.
Yeah, dia tak mention. Okay. Kalau tak mention macam ni macam apa? You tengok example problem ni. Dia cakap 1% chance of tooth bending failure. Nampak tak? Tengok guys, macam ni. Dia mention kan 1% of tooth bending failure. Ini 97% reliability. Faham tak? 99% reliability. Kalau biasanya normally, if not mentioned, is 1 tau. Tapi I don't know why the solution put it 90%. Maybe ada something that I miss ke, atau ada mention dekat sini about reliability. But sometimes, okay. Typical seperti itu. This one 99 pernah respect. Okay, tak apalah, kita ada argue on that. Okay guys, kita need to be quick. Okay, alright. So assume lah 90%. Tapi normally guys, kalau you put 50, you take 50% also, if not mentioned, you can take it 50%. 50%. So it means, sorry, mana tadi your reliability ni 50%. It means kalau kita expect more, kita 90%, understand what I mean? 90% reliability. So we want to be this 90%. So you can take 0.897. Kata this one is just rough. Your reliability is 50-50. Normally tak, logically macam ni lah kelas. Kalau tak mention, my mistake kelas. Tengok, remind me. Take note. Kalau not mentioning, do you want your machine to be 50% reliability or 90%? I'm asking you.
90%.
Yeah, 90% kan. That's the point lah. Betul lah, the lecturer that made the solution is right lah. This is good. Kalau you make this one, I didn't say. Kalau you answer 50, sometimes I always mention keramai mistake. I cakap, kalau tak mention one, tapi depend on situation. Judgment. You as engineer, you gonna be engineer, you kena judge. You don't want your machine to be 50% reliability, right? 50 aiming your machine, 50 pass, 50 will fail. No lah, of course, we want it to be 90% kan. Kalau nak mention me 90%, my mistake guys. I think I did mention two. Kalau nak mention one, tapi that is a totally not a good explanation from me. My correction. For gear kan, kalau not mention, like temperature, yes, right, you say kalau ni. Kalau this one not mention, of course we want our machine to be 90% at least lah, reliability. So use 0.8. So tengok faham kelas? Okay, kelas. Okay, 0.97. KT temperature 1. KM, okay, KMS, be careful. KMS, okay, look, KMS is a mean stress factor because gear, okay, if you look my diagram, gear 2 like this, rotate like this. This is your gear 3. We are asking about gear 3, gear rotate like this. This one rotate like this. So gear 3 then rotate, okay, gear 3, I'm talking gear 3, F tangent from 2 like this. Then they have F tangent from gear 4. F tangent ni gear F tangent 3 to 2. Sorry, 2 to 3. This F tangent 4 to 3. I'm talking this is your gear 3. Gear 3 is idler. Idler factor, your punya air tooth ni will suffer both sides. The tooth, okay, the tooth at the bottom here, they have F tangent like this. When the tooth rotate until this quadrant at gear 4, okay, this one, the bottom surface of gear tooth, but this tooth, when it goes to gear position to suffer the gear 4, the bottom surface is up, but the top surface become bottom. And the top surface pula suffer F tangent from 4 to 3. So it means both sides of the gear tooth have both sides, two-way bending, not one way. So it's worse. Okay, so so gear two-way bending, KMS is statement kat sini, kalau idler 1. Okay. So idler is 1, two-way bending. Idler is two-way bending. So idler is 1. For idler, because gear 3 is idler. So KMS is 1. Tadi kita cakap apa? Reliability tadi 0. Ni kan? Reliability KR is 0.897. Ini my mistake guys. Always take 90%, not 50%. 90%. You want to mention to be 90%, not mention. Kalau mention, be careful. 99, look for 99%. Okay, 99%, you want to be 90% reliability of yang ni lah. 1% confidence. Alright, so you put the value into your SN. Just put the value into your SN. So you get the, itulah you punya, just now our sigma. So safety factor is SN over sigma bending. So you put the value as SN tadi lah, SN, CL, CG. So you put the value there. Okay, all the value is there. Then the SN already calculate. CL, CG, so you got 24 on it. So safety factor tu, you got this one. Okay, you got the SN, 24, divided by sigma. Sigma tadi, we got 83. So safety factor is 3.24. So it's infinite lah. Safe. 3.24 is a good safety factor. Do not for your project guys, you punya tools nanti safety factor 20 something, 16, 17, itu too much guys. And try to go for around like this 3.25. 4 is good enough. It's appropriate lah. Alright, so okay, if number of teeth is change to 25 teeth, okay, kalau ini 30 change to 25, reduce the number of teeth. Kalau reduce number of teeth, so if the safety factor will remain the same, increase or y, okay. Okay, remember your sigma bending depend on your j value. Sorry, because SN over sigma. Remember your sigma bending is apa? F tangent times P over BJ, KB, KO, KM. Your J ni is the denominator. Kalau you reduce the number of teeth, kalau the gear T is changed to 25, earlier is 30, you reduce the number of teeth, what happened to the J? Just let know, J tu ada effect tak? Kalau 30 become 25, 25 you punya ni J will be lower kan? J will be lower. Kalau J will be lower, your sigma bending will be greater. Kalau J lower, sigma bending will be greater. So it will decrease lah. So it will, the safety factor will decrease. Itulah. Okay. 4 boleh tak? Plus. 0 plus. Plus, are you there? Faham Okay. Dalam question ni, there is no surface. Be careful lah. Your test 3, test 3. You punya test 2 ni ada surface. So, what is the equation for surface? Look at my video ada kita sharing video ada kan? Surface stress last kali. Tapi tak ada dalam in this question. Surface stress ada termasuk dalam you punya ni. So, what is surface stress? Dia punya equation macam mana? Surface, come on guys. Surface stress kita ada, okay, surface stress ni, okay, look at my video. A safety factor is SH, surface strength. This is surface strength. Surface strength over sigma H. This is surface stress. To get this sigma H, this is a question. Okay, sigma H is what you call CP is elastic coefficient. Okay, times, okay, we have elastic coefficient times F tangent in the square root, F tangent, okay, we don't have P. Here we don't have P, because surface doesn't have to use with your diameter pitch. F tangent we have already calculated F tangent, B is your phase width, is now 1 inch, and your DP is diameter of your, let's say what diameter, are you working on diameter gear 3 or gear 2, that your diameter, okay, I is the ratio, this one, sin phi, because already given sin phi, this one is not asking like, let's say phi here is given is 20 degree, phi is 20 degree, okay, this one this one kV already calculated, KO and KM is already given, let's say like it's given, they already calculate KV, KO, KM, so CP, this equation, you know again, CP, elastic coefficient, okay, 1 over, okay, CP ni actually guys, kalau you look at, kalau ni, I hope you look on my video, okay, look at my video, how explanation of surface strength, my YouTube video, atau the one that you Jan always shared also, you can, you punya pinion material, what is your gear material, okay, kasi steel, so you can directly, ataupun if not given, you have to calculate like this, manually. Tapi normally you can get from the table. It said the pinion gear is steel and the mating gear, the gear 2 is steel, atau gear 3 and gear 4, for example, gear 3 is steel and gear 4 also steel and steel, so just take this value. Steel and steel, pinion and the mating gear is steel, 2300 square root PSI. So will be here, this one will be, this one is 2300 square root PSI. So F tangent, as usual, we already calculate F tangent is now KV, KO. What is I? I is this one. I is this. I is the sin phi. Sin phi. Phi is 20 degree. Cos phi is 20 degree over 2. R over R plus 1. What is R? R is ratio. R is your gear over pinion. Diameter of your gear 3. Sometimes you don't know what is diameter. Diameter, okay, we know pitch is N over D. Just now, okay, already calculate, kan? Pitch is already, this one is 6 inch, and N over D. To get D is N over P. Okay, this one already calculate just now. So you got your R put into here, R over R plus 1. Suddenly you got your I put into equation. And you CP also you get the value, then you got your sigma H in PSI, be careful the unit in PSI. So okay, this is surface stress, but the denominator is surface strength. Surface strength not CL, CG, CS, no, because this is surface. Yang CL, CG, CS, KT, KR, KMS, SN prime, that one is for bending stress. It's about bending. This is for surface. Surface you punya SH. Surface strength SH, mana? Surface strength ni SH. SH is SFE, CLI, CR. SFE ni based on SFE ni macam bending strength kan, we have SN prime. Surface we have a standard testing for surface strength. SFE is based on this one, based on 99% reliability, 10 to the power of 7 second. This is standard surface strength. Okay, you get the value kalau katakan just now our BHN is apa tadi? 156. So 156, so 0.4 still, 0.4 times 156 minus 10, that will be in KSI. So that will be your SFE. CLI is a life adjustment factor. Okay, you punya life adjustment factor, because standard this one is based on 10 to the power of 7. So kalau you 10 to the power of 7, of course 1. Maybe you punya, based on the question, you said the punya life is 10 to the power of 6. Cycle, you can use this one. This one is 1.1. Okay, 10.6, you use this graph, use this graph for you. Kalau 10.7, kalau is 1. Kalau 10 to the power 8, use this graph. So that will be your CLI. And CR is the reliability factor. Kalau 90% is 1. Sorry, 99% is 1. Because why? The standard SFE is based on 99% reliability. Kalau you 90%, that is based on 99%. So that's why 99% is 1. Kalau 50 or 99.9%, for the 99%, just we have 2. Okay. Either the question give you 99.9, 1. Kalau 99% means 1, that will be your CR. So the SH will be in also, be careful about unit, either KS or PSL, be careful about it. You can look at the sample problem here. Okay. Case, unit, that will be your safety factor. Safety factor, SH over sigma H. Okay, class? Boleh faham Okay. Alright, class. I think that's all. Sorry for taking your time. Ada question tak? Aware about this? This one we have about the class surface we have in your gear. Question 3. Ada surface sekali. Surface I think is pretty straightforward. You just calculate your sigma H. Ada problem to you know how to calculate this thing kan, and your SH. Class, are you there or not? That's I'm talking ada. Yes. We have it. Tapi pretty straightforward lah. Just kind of like straightforward. You just calculate. Calculate je. You know FT already calculate from the can. Previously we already calculate B, we know is 1. Phase width is 1. The diameter pinion, we know already diameter of the gear. Diameter pinion means the gear that you are working on. What you are focused, pinion gear or which gear? So what is the diameter? I already this equation. R over 1. R to ratio of your tooth and your mating tooth. R is the diameter of your gear and the mating gear. That's R. The difference of the diameter, that's R. So you just put into equation R, this I will be put here, then you get this sigma H, and you calculate the surface strength, SFE, CLI, so you get your near. Okay, so the safety factor is SH over sigma H. That's it. Okay. Kalau look on the sample problem lah, tapi sample problem is more calculate the maximum most per year in terms of variable FT. So mean safety factor is 1. The border of 1, border safety and failure. What is the maximum horsepower? If you want to calculate power, you look on the example. You can look how they calculate. I think it will be in KSI. And be careful about unit guy. Sigma H will be in KS. SH will be in KSI. Your sigma H also will be in KX. I convert it. Okay, convert it into PSI because KSI SH times 1000. Be careful about unit. That's my point. Be careful about the unit. This one 97, say 100 PSI times 1000. You can look the sample problem on. Yeah. Okay, class. I think that's all. Then we go for attendance. Sorry for taking your time. Kita tak ada kelas on no class on Thursday. Sorry.
Okay, doctor, thank you.
Nanti kejap, attend lagi. Session 8. Class, are you there? Kejap, saya share attendance kejap. Okay, class, scan your attendance. Correct. Good luck in your exam. Okay, Assalamualaikum warahmatullahi wabarakatuh. Welcome.